So let's talk about a battle of survival that's happening right outside your window right now. We're not just talking about staying cool. We're talking about the incredible, hidden engineering that stops an air conditioner from literally melting in the extreme desert heat.
And that brings us to the main question. Why is the desert so absolutely brutal to our AC units? I mean, it's not just that it's hot. The desert environment is an active attacker, systematically trying to dismantle this crucial piece of technology.
You see this number? 115 degrees Fahrenheit. In places like Phoenix or Palm Springs, that's not some crazy record-breaking heat wave. Nope, that's just a normal summer afternoon. And that is the temperature an AC unit has to fight against before it can even start the job of cooling your house down. So, that brings us to our first section, the desert's assault. And you really need to think of the climate here less like simple weather and more like a relentless enemy, one with a very specific set of weapons it uses to attack your AC.
Now, what's so critical to understand is how all these things stack on top of each other. It's not just one thing. The AC runs constantly for 8, maybe 9 months a year, putting what feels like 5 years of wear and tear on it in just one season. Then you've got these insane temperature swings, from a baking 115 during the day down to 70 at night, which stresses every single metal part. And on top of all that, you have a constant sandblasting of fine dust. It is the absolute perfect storm for mechanical failure.
And this is where it gets really serious. You know, if your AC breaks in a mild climate, it's annoying, you're uncomfortable for a bit. But in the desert, it is a genuine safety crisis. The temperature inside a house can soar to dangerous levels so fast that the home becomes literally uninhabitable. This machine's survival is directly tied to our own safety. So how exactly does this breakdown happen? Well, let's do a little forensic analysis, okay? We're going to look at how a standard off-the-shelf air conditioner is systematically taken apart by that arsenal of desert weapons we just talked about. It always starts with the compressor. That's the heart of the whole system. Now, it's basically a big pump, and like any motor, it creates its own heat when it runs. It relies on the air around it to cool off. But what happens when that air is already 115 degrees? Well, it can't cool itself. It goes into what's called a thermal shutdown. It's like a sprinter just collapsing from heat exhaustion mid-race. So with the heart already struggling, the desert goes after the lungs, the condenser coils. See all those little fins? They're designed to release all the heat pulled from your house into the outside air. But the desert winds coat them in this thick, insulating blanket of sand and dust. This traps the heat inside, forcing that already strained compressor to work even harder. It's a vicious cycle. Now think about those constant, extreme temperature swings day after day. All the metal refrigerant lines expand in the heat and contract in the cool, over and over and over. This relentless stress creates tiny, micro cracks and pinhole leaks. The system slowly, quietly bleeds out its refrigerant, losing its ability to cool, which, you guessed it, forces it to run even longer.
The final nail in the coffin is the electronics, the brain of the operation. Components like capacitors and control boards are sitting out there in that metal box, baking in temperatures that are way beyond what they were designed for. Capacitors start to bulge and fail. Contactors can literally weld themselves shut, and the circuit boards get these tiny little cracks. The system's brain is, for all intents and purposes, cooked.
Okay, that was pretty grim, right? That's the breakdown. But this is a story of survival, which brings us to the solution. So how do you actually engineer a machine to withstand that kind of non-stop assault? It's not about just making one part a little stronger. It's about building a totally different class of equipment from the ground up. This comparison right here is the heart of the solution. So instead of a standard condenser, a desert-rated unit has a much larger, oversized one. Why? More surface area to get rid of heat. Instead of basic capacitors, you get commercial-grade ones built to handle higher temperatures. A hard start kit gives that compressor an extra jolt of power on startup, which reduces a ton of strain. And that high SEER rating? It's not just about saving a few bucks on your electric bill. It means the parts are way more efficient, so they run cooler and last a whole lot longer.
But here's the thing. You could have all the best desert-rated parts in the world, and they will still fail if the installation is sloppy. The sizing of the unit has to be perfect. The refrigerant charge has to be exact, not just close enough. And sealing the ductwork is absolutely critical. I mean, think about it. Leaking all that precious cold air into a 150-degree attic forces the system to run nonstop. A system's real lifespan is decided on the very day it's installed.
So, what does all of this engineering talk really mean for you? Well, based on everything we've just covered, here are a few simple but really powerful rules for anyone living in an extreme heat climate.
First up is the $5,000 rule. It's a great little guideline. Let's say your AC is 10 years old and it needs a repair that's going to cost $600. You just multiply the age, 10, by the cost, 600. That gives you $6,000. Since that's over the $5,000 threshold, it's a strong sign that you're probably better off putting that money toward a new, reliable system instead of just patching up an old one that's already on its last legs.
Now this next one is huge, and it's really all about managing your expectations. It's called the 20-degree rule, and it's basically a law of physics. If it's 115 degrees outside, a perfectly working AC might only be able to get your house down to 95 degrees. It's not broken, it's just hitting the physical limits of heat exchange. And just understanding that can save you so much stress and a lot of pointless service calls during a major heat wave. And finally, a super simple tip that could literally save the most expensive part of your system. If the power flickers or if you turn the thermostat off and on again, just wait 3 minutes. Give it a pause. That little bit of time lets the high-pressure refrigerant inside equalize. Trying to restart it instantly forces the compressor to work against insane pressure, and that is a major cause of failure. It's a small thing that makes a huge difference.
So, we've seen the assault, the breakdown, and the incredible engineering that helps these machines survive. It all really comes down to this one question for you to think about. Is the most critical appliance for your family's safety and comfort actually designed to handle the place where you live? Something to think about. Thanks for joining me on this explainer.